Hello everyone, welcome back to my channel. My name is Piyush and this is day 20 video in the series 28 days of Easy Terraform. In this video we'll be doing another amazing project and it's about AKS cluster creation using custom modules. So we'll be writing some custom modules and we'll be provisioning AKS cluster using that along with some other services such as resource group, Azure Key Vault, Azure Service Principal, and that's about it. So if you are enjoying the series till now, make sure you complete the comments and like target of this video as well, which is going to be 100 likes and 100 comments in the next 24 hours, and then I'll unlock the next video. So without any further ado, let's start with the video. Okay, I'll explain in a bit about modules and why we use it, why do we need it. I'll do that afterwards, but first let's understand the structure of this project, like what are all the resources we'll be creating, how we are creating it, and like what are the relationship between them. Okay, so let's do that. So over here it's my AKS cluster. As we have mentioned, like we will be using custom modules which will be explaining in some time. Now what we are doing, like let's say you are a DevOps engineer or a Kubernetes admin, or like you are part of that team who manages all the infrastructure in your organization. So you actually, the first step is you will call the Terraform configuration. You will execute the Terraform commands, tfplan, tfapply, and so on. And you will create a resource group. It's not mentioned over here, but this is like, let's call that a resource group. Okay. So you will basically create a resource group first. Okay. And then basically you will create a resource group and then you will create a service principal. Service principal, why do we need it? We need it to manage our AKS cluster later on. We'll use that to provision our AKS cluster and to do the deployments to it, like what we have done earlier as well. Okay, so this service principal will grant contributor access so that it will be able to manage the resources, create new resources, update and delete the existing ones, and so on. And that was the first step. The second step is will also create a Azure Key Vault. Okay, why do we need it? We need it because the service principal that we created earlier, it creates some secret credentials, like it will have secret ID and password. So those secret credentials will be storing as a secret in Azure Key Vault. Okay, to access it securely, to store it securely, and so on. Okay, so create a service principal, create a key vault, and create a secret in the service in the key vault to store the secret of service principal. That's what we have done. And then basically we'll use this service principal to provision an AKS cluster. Okay, so these are all your resources that will be created. Once that is done, so you're, again, you as a DevOps engineer or a kube admin, you will retrieve the secret from the key vault, the one that you've created from the service principal, and using that secret you will do the deployment to your AKS cluster deployments, and basically the further maintenance that is outside Terraform. Mostly you will use that service principal in your CI/CD pipeline, or if you are doing a manual deployment or manual changes, then you will use that service principal to do that changes for you. So that's the overall projects that will be implemented. And now let's have a look the nitty gritty of it. Why do we need it, modules, and so on. Okay. All right, so let me walk you through the source code and what it is, because we have not covered the modules yet. So let me give you a brief overview of what modules is. So modules are nothing but a reusable piece of code that we can use over and over again in a Terraform configuration. So let's say we want to create an AKS cluster, or 5 AKS cluster for that matter of fact. So instead of writing that resource block 5 different times in the same configuration or different configuration, we create a reusable module for AKS cluster. We provide all the values to it, and then we call that module 5 different times by passing different values of for the input variables, like cluster name, location, and whatever the changes are, maybe like let's say 3 4 values based on the input variables. And based on that it will create those 5 cluster without us complexing the code, or without us making things over complicated for us to maintain. So that's why we use function module. So this is like why we use functions in any programming language, or why we create any reusable modules or any reusable piece of code, right? So that's the important part about it. Now modules can be of different types. So there are local modules, that what we'll be doing in this video. So we'll create the local modules, and then the next step is you can also publish these modules to a remote registry. Like it could be a private registry, or it could be a public registry such as HashiCorp, Terraform, over there. So so that if you are publishing it on a public registry, everyone can use that. But if you want it to be restricted within your organization, to so you create a private registry within your organization infrastructure, and then you publish your modules to the private registry, so that your team members or other teams within your organizations can have access to it. So that's the different type of modules. Now let's see how to work with it. So first let's understand the directory structure a little bit. So over here, so I am in my day 20 folder. Okay, over here, if you can see, we have different files. So we have main.tf, output, provider, the same files that we were using earlier, and then we have tf vars and variables. So this is pretty familiar, what you were already been doing since the first video of this series. Now, even if you were not using any modules, you are still using the root module. So when you create some file with the .tf extension or .tf.json extension within your Terraform directory, and you run tf in it, so Terraform consider that as a root module. So you were still using the root module without you even being aware of that you were using the root module. Okay, so that's the root module. Now we have main.tf. Let's start with from here. So we have created a resource group. That's fine, you already know what that is and why do we do that. Now we create a block called module. So we start with the keyword module and then the local name, like over here resource group name has rg1. Okay, so that's the local name of this particular calling module. Okay, so that's your calling module, from where you are calling something. You are calling the child module, and which module you are calling, so that would be there in this source file or the source parameter. So source equal to dot slash modules. That means in the current root directory where you are, in that there'll be a folder called modules, as you can see, and inside that there'll be another folder with the name service principal. So if you expand this module, so we have three different modules created: service principal, Key Vault, and AKS. So this particular block is calling the service principal module. Okay, so just to recap, this is a root module, and then this is a calling module, module service principal, and this over here is the child module which we are calling. So these three type of modules we are talking about. Now we have specified source, which is mandatory field, and over here, like, what values should we give? We give the values related to this particular resource that we are using as a input variable. So for example, if we go to our variables.tf file, terraform.tfrs, or let's say where are input variables.tf. So related to the service principal, we can see that we have service principal does not need a resource group or a location. It's a global resource, but this is the variable that we are using. So the same thing we have provided over here, service principal name. Now from where it is getting, it is getting from the variable. Okay, and then we have also created an explicit dependency on the resource group. Why it is needed? We want to make sure that service principal is created after the resource group. Okay, although there was not any need to create the dependency, but it's fine. Okay, so these two can be created independently as well. Now why are we creating the service principal? I'll show you the module as well, but just let's understand why are we creating the service principal. We are creating because when we'll be provisioning AKS cluster, we will not be creating it from the user ID or the personal ID. we'll be creating that with the service principal. So we'll create a service principal, we grant it contributor access, and we'll use that service principal to provision our AKS cluster. Okay, so now let's go inside this module and let's see the structure of it. So we have three folders. First is service principal. Service principal has the similar files, main.tf output variables. You can add tfr as well if you want, but there is no need over here because we are providing the values at the over here, right? So if you go to main.tf, you see this is pretty similar to what we were doing in the root module, right? So we are doing the same thing. To create a service principal, we have created a data source. We created an Azure AD application resource, and then Azure AD service principal, and then service principal password. This is exactly the same thing that we were doing without using custom modules. Okay, it has all those fields, and then it has some output variables. Okay, output variables is tenant id, service principal object id, service principal name, blah blah blah, client secret, client id. Why do we need this? Because what we are doing basically in this, we are creating service principal, then service principal will generate some confidential data, like client id, client secret, and we cannot just provide that as an output to the screen. It will be a sensitive value, or we cannot just uh, you know uh, we don't want it to be exposed. So basically what we are doing, we are creating output variable, and then we will be uploading these values to the Azure Key Vault by creating a secret. I'll show you afterwards, right? So that's what we are doing. That's why we have output variables. So because when we need to get some values from the child module, we have to output that from the child module so that it could go to the root module. Okay, so we'll go back again. Okay, so that was service principal. Now we'll be creating a role assignment. Now as you can see, we have not created a custom module for the role assignment because you don't want to overcomplicate things by making overuse of the modules, right? So use it whenever there is a necessity for that. So what we are doing, we are creating a scope that apply this role assignment at this subscription level, give it contributor access and principal id, like to which particular service principal we can get it from module dot service principal object id, right? So this is how we can get the value from a module dot service principal, module dot local name dot the value. Okay, and this service principal object id will only be getting if we have that in the output variable of that child module. So if you go over here, so you should have object id. This is the one. Okay, now let's move. Now yes, we need to have a dependency for on the service principal module, because you cannot assign a role to a service principal that does not exist. It will fail then. Okay, so explicit dependency is required. Then we are creating a key vault. Again the same thing, we have created a key vault module. Source is the same, and over here we have provided all the input variables related to the key vault resource. So it should have a name, location, resource group name. If we have not provided, like if we have not created the input variable for that, then there is no need to provide the name, but then it should have those variables defined somewhere in the module itself, the child module itself. Okay, so source, key vault name, location, resource group, service principal name it will get from the variable, and rest of the details, object id, tenant id, it will get from the modules. Now these two are the output variables of service principal modules. That's why we are able to access it over here. Okay, then we have Azure RM Key Vault secret. Now this is the part that I was mentioning. So you have created a key vault, you have created a service principal. Now you have to create a secret of whatever values you have gotten from the service principal, like client ID, client secret, all those things. You have to create a secret out of it and upload it to the Key Vault. So for that, you create a resource Azure RM Key Vault. Okay, and name would be your client ID and client secret. Sorry, name is your client ID and the value is your client secret. Client secret is the output variable and client ID is also the output variable from the service principal module. And you have to provide a key vault ID, like where you want to create this secret as well, right? So modules key vault ID, that's it. And then over here we are creating a AKS cluster. Okay, again, source, service principal, client ID, client secret, because we want this AKS cluster to be created from a service principal. And then the input variables, location, resource group. So you see, our AKS cluster will be provisioned using just these few lines of code. And if you have 5 cluster, you can just copy it and call the module again. But if we were to do that using the traditional approach, the root module approach, let's say what we have in our AKS cluster main.tf, so it has these many things. Okay, it will be an overcomplicated thing. Okay, so what it has, the AKS cluster, first we have a data source. Okay, why do we need a data source? We want to make sure that we are using the latest version of AKS cluster while provisioning it. So we create a data source of Azure RM Kubernetes Service version, and we are like, this is the just the data source, and over here somewhere, let's see, Kubernetes version, we are taking it from data source dot Azure RM Kubernetes Service version dot current, which is the local name, and latest version. But let me add a to do item over here. So instead of doing that, instead of getting that latest version, you have to add an additional check if there is a variable with the version name. If not, use the latest version from data source. If there is a var, use that version. Okay, so for example, if you are using, let's say, 1.30.2, okay, if you have provided that in the variable, so use that version to provision the cluster. But if it is null, if the user has not provided the value, the default should be the latest version. So you need to add a conditional statement for that. Okay, now there is this check that you have to perform, and then make sure that version is valid. Make sure the version specified in var is valid, right? So it has to be in a certain format, like 1.30.2 hyphen something something. So you can check the version, like what a valid version of Kubernetes cluster is, and you need to make sure that you are using that validation. Okay, now it has name, location, resource group, DNS prefix, Kubernetes version, node resource group, because AKS cluster creates a separate resource group for the node pool where all your nodes will reside. Here is the detail of default node pool. That's the name. You can use variables, of course. VM size, you can restrict to use a certain type of VM size as well, like we did earlier. And then max count, min count, because it's all part of a virtual machine scale sets, like we have auto scaling group in AWS. Then there are labels that will be applied to the nodes, and these are the tags for the node pool itself. Now here are the service principal details and Linux profile, where you are using a locally generated SSH key and providing that as the authentication to SSH into the cluster with the username as Ubuntu. Now over here as well, let's add one more to do item, which says generate the SSH keys using TLS private key resource. So if you can just check in the Terraform documentation, this is a type of resource which will help you generate these keys instead of using the local keys. So currently, if you can see var.ssh public key, what I'm using over here, Terraform variables. Okay, not here, sorry, inside the same module, variables. Okay, so you can see I'm using um, the SSH key in my home directory. So with that, um, like the to do item, you can generate an SSH key using the private key and use that over here. Okay, and then you can also upload that private key of that key value pair to the Azure Key Vault, like what we did for the upload the key to Key Vault. Okay, and then network profile. So that's the AKS module. Let's go back to a root module. So AKS is done. Now we are using a resource of type local file. That means we are creating a file based on some content from somewhere. Okay, so we are generating a kubeconfig file which depends on AKS module. Okay, and the file name is this in the home directory. Content is from modules.aks.config. Okay, so this kubeconfig file will help us authenticate into the cluster. So that's the main.tf, and we have seen other things as well. Now we can make some more changes to it to make it more advanced. Like I've said, use variables wherever you want, use all those things that we have mentioned in the to do. And let's see if we are missing anything. Oh, I guess that should be it. So let's just apply this first. Let's do a tf plan. Grep will be created. Let's see how many resources will be created once we execute this tf. So we have a secret, resource group, role assignment, kubeconfig. That would be your service principal, Azure application. So these are like modules, resources within the modules actually. And then from AKS module, AKS cluster will be created. From keyword module, keyword will be created. Okay, so these many resources will be created. Let's hit tf apply, and hopefully there are no errors. And let's see, 9 plans to add. So now we'll wait. I'll just pause the recording to let it provision. Okay. Okay, so it says that all the resources have been created successfully. Now let's see. Mhm. Okay, so if we go to resource group, hit refresh, test. So you can see there are two resource groups. One is for node groups. So let's, if we click on that, it will have AKS agent pool, default pool, virtual network, public IP, and load balancer. And if we go to the resource group, it will have AKS cluster and keyword, meaning the other resources. So if you go into the cluster, okay, and by the way, you can also upload the kubeconfig to keyword as well if you want. Okay, so if you go to, let's say, namespaces, we have the default namespaces, and let's see the workload if they are healthy. Okay, so we can see that the control plane components are like the workloads that are specific to control plane components are healthy. And if we check other services, so this is all the default cluster IP services that comes with the cluster, so these are also healthy. And let's see if we have any errors. No errors. It says starting kubelet, it will be on the node pool, and it says invalid capacity on file system. It's because the nodes are still warming up, so that's all right. I mean, initial warnings are okay. And let's hit refresh. Yeah, it should be up, no worries. Now let's check the node pools as well. Resource group and vmss, so inside that will be our node pool. Instances. So currently one is up because we had min 1 and max 3, I believe. Yeah, so this is up. Let's see. Yeah, 1 out of 1 is succeeded because 1 is what is expected. Instance count is 1, and yeah. Okay, so this is also good. Now, okay, now the next part, what you can do is, I could have done this. It's just pretty simple and straightforward, but I want you to perform this activity by yourself because I have provided every single piece of code other than that. So what you can do, you can go to this repo. I'll share the link in the GitHub repo and with all the instructions. Don't worry about it. So this is the repo. This is basically an open source project by Google Cloud, and it's called Bank of Anthos. Okay, it has, as you can see, multiple microservices. It has some load generation application. It has a front end that will be deployed as a load balancer service. It will have some backend services, multiple database, and all those will be deployed as pods in Kubernetes. So to do that, what you can do is you can clone the repo, clone this repo, not the official Google Cloud repo, because that was meant to be only executed on GKE. I have made some changes. I have disabled some flags to make it run on any Kubernetes cluster. Okay, so if you want to do that by yourself, you are welcome to go to that repo and make the changes as per there in the documentation. But to avoid that, you can just clone my repo and start working with it. Okay, so clone it and then apply the manifest in the Kubernetes manifest folder. It will have different deployments, YAMLs, services, and then secrets from this folder. Once that is done, you will see these pods are up and running: account DB, balance reader, contact, front end, and so on. And front end is the external service that are exposed, that has been exposed. So you can go to that in a web browser, and basically the login page will be opened. Rest of the details you can check from here in the documentation, with like the login credentials and everything. I guess it was there somewhere. um but it will be basically like this. You will be presented a home page. You log in using test user is the username, and I guess try with the same password. And then you will have different other services calling the backend and calling the database. You can try to deposit funds, send payment. It's like a virtual online banking system. Yeah, so try it out and let me know what you think about it. You can do that, as I've told you, you can do that with the Terraform provisioners such as null resource and kubectl, or you can further enhance it by creating a CI/CD pipeline out of it. So it totally in your hands how well you want to expand this project to a full-fledged end-to-end DevOps project. I have provided you the code in the GitHub repository, so you can take it from here. Try it out yourself. It will be fun. It will be a good learning experience if you try it out yourself first without just copying the code and everything. But make sure you understand like everything what we have discussed so far. Okay, so that's an end-to-end project in which you have created multiple resources including a Kubernetes cluster, and you did that with the help of custom modules in Terraform. Right, this is one of the industry's best practices. And then you can further enhance it by deploying a full-fledged application to it, such as Bank of Anthos, which has multiple microservices, front end, back end databases, and so on. Okay, so try it out and let me know what you think. Make sure you complete the comments and like target. I will see you soon with the next video. Thank you so much. Happy learning.